Hi everyone, so today we're going to be doing notes on section 2.6, which is all about absolute value inequalities. Remember, this abbreviation that I use means inequalities. So go ahead and take a second to pause this and write down this chart. All right, so the inequality, there are two different kinds. When we have the less than or equal to symbol, or the greater than or equal to symbol. Those are the two different cases we're going to be looking at. So let's first start by looking at the blue ones, the less than and less than or equal to. I refer to these as less than. They have an and in it. What this means is that when you take the absolute value bars off and write it as a statement you can actually solve, it's an and statement, which means your graph or your solution that you graph is also an and statement, like what we saw before with the number lines. The and statements, they go together in the middle. Then greater than or equal to. These are the greater means that when we take the absolute value bars off, it's written as an or statement. This or that. This or that. Which means my graph of them, the graphs are going to go away from each other. The little arrows point away from each other. So those are the two things that we're looking at. And the first thing we're always going to ask ourselves is, with every single one that we solve, is it greater than or is it less than? Less than, greater. Let's go ahead and look at a really simple example. This is one where it's just x by itself in the absolute value bars. We don't have to move anything over to the other side. I just want to practice doing the greater than and less than symbols so that when we get to ones where we actually have to solve, we've already practiced. All right, so first thing I want to ask is, this inequality, is that less than or greater? Good, you should have said less than. Which means this is going to be written as an and statement when we solve it. Now, the way we do that is I just rewrite this without the absolute value bars as exactly as I see it. But then the thing that gets added is the -4 on this side and an absolute value bar an inequality going the same direction. That's our answer. And then when we graph this, I'll put a point at 4 and -4. When I graph this, it will be an open circle at -4, an open circle at +4, and x is literally written in between 4 and -4. So the answer is literally everything in between -4 and 4. So that's the part that's building off of your last section of notes. When the answer is written like this, doing your graph. So now the only thing we're changing is we're adding this first step of dealing with absolute value. But from here and the graph should be review from the last notes. Let's go ahead and look at this next one. So first thing I want to ask, less than or greater? Good, you should have all said greater, which means it's going to be two separate statements with the word or in the middle. So again, first thing I do, I write this out exactly as is, but without the absolute value bars. Or x, I'm going to flip this the other direction and change this to negative. That's my answer. And then to graph this on a number line, again, I'm just going to put a point at 4 and -4. Now for this one, open or closed circle. Good, you should have said closed, +4, and it's everything greater than that or bigger, which is going to the right. This one is also a closed circle at -4, and it's everything smaller or less than, everything going to the left. And there we go. Two very basic examples of an and or an or statement. Let's look at two more examples. So go ahead and pause this and take a second to write these down. For the first example, if you notice, my absolute value is not by itself. So the first thing I need to do before I can determine if it's an and or an or, I need to get the absolute value by itself. So to do that, I'm going to divide both sides by -3. So this becomes the absolute value of 2x. This side becomes -10. Now when we have division, when we divide both sides by a negative, what do we have to do? Good. You all should have said flip the sign. I'm just going to draw a little arrow to that so you see that that happened. Or it flipped really small. Now it is by itself. My absolute value is now by itself over here. So now I can determine, is this greater or less than? Good. You all should have said less than, which means it's going to be an and statement. But it's saying this absolute value is less than a negative number. Is an absolute value allowed to be negative numbers? No, it's not. Which means if this has to be smaller than a negative number, it has to be a negative number, which it can't be. It's not possible. Which means the answer to this is no solution. And I'll put a little note. The absolute value can't be smaller than 0. So not negative. Let's look at a different example. Part B. Oh, by the way, for this one, since it's no solution, that means we have nothing to graph because nothing is a solution, so we physically have nothing to put on a graph. For this one, now I want to get my absolute, oops, sorry, the document camera just disappeared. There we go. So this one I need to get my absolute value by itself. I have a few things in the way. I have this 2 that's multiplied and this 1 that's subtracted. So first thing I'm going to do is subtract 1 from both sides. I get 2 times the absolute value of x minus 2 less than or equal to, oops, that should say 15. I'm sorry. Let me fix this. I wanted that to be a nice even number and not have fractions. Change that to 15. There we go. It's less than or equal to 14. Now I'm going to divide both sides by 2. So I get the absolute value of x minus 2 less than or equal to 7. Now this one is also a less than, which means it's going to be an and statement. So I'm going to rewrite this exactly as is, just without the absolute value bars. And then on the other side, I'm going to add a -7 and draw this so it's going the same direction as that inequality. Now I'm almost done, but I still have to add 2 to the middle, the left, and the right. Remember, keeping it balanced. So now it's -5, x in the middle, 9 on the right. I'm sorry, I have hiccups. Sorry if you can hear them. And our last step is to graph this. So I'm just going to draw a tiny little graph. Sorry, I kind of was crunched for space down here. At -5, open or close circle? Good. Should have said closed. And then at +9, it's also a closed circle. Now, x is literally in between -5 and 9. So on my graph, it is literally what's in between -5 and 9. That's my answer. And there we go. Next example, I want you all to try these two on your own. And I want you to notice this first one, your absolute value is already isolated. The second one, you need to get the absolute value by itself first. And you're always looking for the greater or less than. So I'm going to go ahead and pause this video. Pause it on your end, and when you're ready to check your answers, push play. Go ahead and check your answers. So part A, the absolute value is already isolated by itself. So we were able to look at it and see this is a greater, which means it's going to be 2 separate statements. First one, we copy it exactly as is, just without the absolute value bars. The second one, we flip the sign and make it negative. Solve both of those, and we get a graph with open circles going away from each other. Second one, part B, we had to subtract 1 from both sides first. Then my absolute value bar, or absolute value, was by itself. So now I can look at it and see this is less than, which is an and statement. So copy it exactly as is, and then add the negative option to the left-hand side. And whatever you do to the middle, you have to do to the left and right side. So you should have ended up with 2 closed circles that are combined in the middle. Now that you've had a chance to do 2 practice problems on your own and check your answers, I want you to go ahead and try 2 last problems on your own. Now, neither of these have the absolute value bars isolated, which means you need to get the absolute value by itself first. Go ahead and pause this video, and when you're ready to check your answers, push play. Go ahead and check your answers for the last example. So for part A, we had to divide both sides by -2, which makes our sign flip. Forgot to write that, so I'll go ahead and write that there. Makes the sign flip when we divided both sides by a negative number. Then my absolute value is isolated. So I know that this is a less than, which means it's going to be all one statement. Add 2 to the left, middle, and right. Our final answer, and then our graph, which are both closed circles because these both have the or equal to. Part B, I needed to add 1 to both sides first, then divide both sides by 3. Since I divided by a positive number, the inequality stays the same. Now that my absolute value is isolated, I can look at the inequality and say, all right, this is greater. So I set up my 2 separate statements. One that's written exactly as is, and then the other one I flip the inequality and make the answer negative. Solve both of those, which will both be open circles and look like this. That is the end of our notes. Have a good rest of your day.